Okay, good afternoon. This is Sunhyoung from A3. This paper deals with ATSC 3.0 transmitter identification in multiple transmitter environments. Okay, this is agenda. First of all, I will explain the basic concept of TxID, including why TxID technique is essential in single frequency network environments. Next, I will explain how the TxID is generated and inserted into the ATSC 3.0 frame. In order to take realistic scenarios into account in an SFN environment, and let's look at multiple transmitter scenarios and the difficulty of TxID detection in these cases. Through computer simulation, laboratory tests, and field tests, we will see the detection performance of TxID in such multiple transmitter scenarios. And then conclusion. In the first generation of digital terrestrial broadcasting, such as ATSC 1.0, at that time, multiple frequency network is commonly used because the design and management of the network is quite convenient, and both transmission and reception sides are easy to implement. However, as you know, such a multiple frequency network is a very inefficient way in terms of spectrum usage. So nowadays, the efficient use of radio spectrum resource is a very critical issue in any kind of wireless communications, also including the terrestrial broadcasting system. So therefore, in ATSC 3.0, SFN-based terrestrial broadcasting has been actively deployed, for example, in South Korea. By constructing a terrestrial broadcasting system with SFN instead of MFN, it is expected that not only we can get enhanced spectrum efficiency, but also the reception signal strength will be quite improved, and the service coverage also will be expanded. So this is the status of the future plan of deploying ATSC 3.0 in South Korea. At first, in 2016, the standardization of terrestrial UHD TV for Korea was completed by accepting ATSC 3.0 standards. At the end of May 2017, South Korea launched the world's first commercial terrestrial UHD service. And then at the end of the same year, major cities are also serviced by ATSC 3.0. And then for the next step, we expect that at the end of 2021, all the areas in Korea will be covered by ATSC 3.0. Okay, then in terrestrial broadcasting, measuring the channel profile and signal strength of each transmitter is very important in order to design and manage broadcasting service coverage. So one of the main goal of TxID is to help broadcaster can measure channel profile of each transmitter individually. So as you can see this figure, channel profiles in blue and red can individually detected by using TxID. And then why? Why TxID is so important? What if we don't have TxID? So let's imagine that we don't have any TxID functionality. In this case, we have to turn on only one transmitter at one time that you want to measure, like the leftmost TxID in left figure. So I would say it is on-off approach. But it is impossible to use such method during regular broadcasting time. So you have to use like that method like during the night. So in order to overcome this kind of inconvenience, ATSC 3.0 has adopted TxID technology. So this technology is RF watermark technology based. In other words, TxID signal is transparent to general receivers, such as commercial TVs. So moreover, there's no additional redundancy in terms of data rate, even if TxID is on. Next, how do we make TxID signal? It is generated separately from the normal TxID, normal ATSC 3.0 signal. So pink block diagram is corresponding to normal ATSC 3.0 signal generation, and the upper part, TxID generation, is colored in blue. So basically, gold sequence is used in order to generate a sequence for TxID. And then it is modulated by BPSK and injected into normal ATSC 3.0 signal. Because the clock rate of TxID signal is approximately 6.9 megahertz. So it has a bigger frequency bandwidth than the normal ATSC 3.0 signal, as shown in the figure below. So as we can guess, some part of TxID signal can be cut off through a mask filter. So it's totally depends on how mask filter sharply cut the frequency band. In ATSC 3.0 system, TxID signal is injected into preamp part only in order to minimize the performance degradation of the host broadcasting service due to TxID. So TxID is added to the host ATSC 3.0 signal from the beginning of the first preamble symbol in time domain, so which means just right after the end of bootstrap. And the allowable TxID injection levels are defined as in the specification as shown in the table, which are from 9 dB to 45 dB, and also includes an option for disable. And as I said, TxID has been proposed to distinguish the signals from each transmitter. It means that a TxID signal should detect multiple transmitters at the same time. But in such cases, as we can easily expect, it is quite challenging, actually. So here are some scenarios related to that problem. In the first scenario, assume that the power of each received signal of two different transmitters is the same. And then the combined host signal power, which is colored in black, is increased by 3 dB. So the effective injection level for the TxID signal, for both of TxID signals, red and blue one, the effective injection level is also increased by 3 dB. So it's a kind of mild situation. But on the other hand, in the second scenario, let's consider two reception signal powers are different. In this case, of course, the TxID signal corresponding to the transmitter with dominant signal power can easily be detected, which is the TxID number 2, blue one. However, it's not that easy to detect the TxID of a transmitter having a lower signal power. So here's a TxID number 1 colored in red. So how difficult is it? So it depends totally on the power difference between the the reception powers. So as a result, the effective TxID injection level of the transmitter with weak reception power can be defined as like the original injection level plus the amount of difference between the reception signal when the power difference is sufficiently large. So here's another example. If we look at the second scenario first, then the power difference is, we assume 6 dB. So in the viewpoint of the weak signal, so which is TxID number 1, so it is almost the same situation as for transmitter case in the first scenario. So I would like to say, like, even if we have just 2 transmitter in SFN, so it could be somewhat serious than you expect. So in order to investigate the TxID detection performance in these multiple transmitter scenarios, we first have done some computer simulation with the system parameters here listed in this slide. We have set an 8K FFT size and guard interval number 6. And for TxID injection level, we use 9 dB to 33 dB. And the arrival time difference between the received signal from each transmitter is assumed to be 7 samples. So in time scale, like approximately 1 microsecond. And each of received signal power is set to 15 dB CNR under AWGN channel. Channel profile of each transmitter can be obtained by conducting the correlation operation between the received signal and TxID sequence. In this figure, the blue line graph represents the correlation values. Since AWGN channel is considered here, there's no multipass, so we can observe just one peak here. In order to quantify the detection performance of a TxID signal, we are using signal to DTV noise ratio as an evaluation metric. So this metric was also used in ATSC 1.0. And it is defined as the ratio of the desired signal level and the noise level of the correlation values. In this simulation, it is assumed that the highest peak is regarded as the signal corresponding to the desired channel profile, while other values are regarded as noise. So only here, this peak is regarded as desired signal, so channel profile, and then the other blue values are regarded as noise. So here are some examples of TxID detection result with various SDL values. So as shown in these figures, when SDL value is less than 10 dB, the rightmost figure, then it seems that channel profile cannot be detected correctly. So therefore, in this paper, it is regarded as detection failure when SDR value is less than 10 dB. But even if SDR value is slightly greater than 10 dB, I would say it's quite close to the detection failure condition. So it's not guaranteed a stable TxID detection. Okay, this is the simulation result for TxID. And according to the number of received signals at TxID analyzer, so from 1 TxID to up to 15 TxID, 15 TX transmitters. So in this simulation, we as I said, it is assumed that the received signals corresponding to each transmitter are equally 15 dB. The larger SDR value means the better the detection performance. So as you can see, the blue line, which is corresponding to one transmitter case, this blue one, is corresponding to one transmitter case, shows for sure the best performance. So for such a single transmitter case, the TxID detection is successfully performed up to 30 dB injection level. However, whenever the number of received signal doubles, the TxID detection performance drops by 3 dB. For example, when 16 signals are received, even here, like 18 dB injection level is very close to the detection failure condition. So what I want to mention here again, even if there are a few transmitters and if they have different reception powers, then the detection performance can be seriously degraded for the weak signal. Such reception power imbalance situation, actually it is more realistic and very common in real broadcasting environments. Okay, here's another simulation result. We have conducted not only computer simulations, but also laboratory and field tests. In most cases, only 2 dB difference between simulation and field test result. So I would say they are well aligned in general. When there are 2 received signals, the TxID detection performance is degraded by 3 dB compared to only 1 transmitter case for all types of tests. Okay, here's the conclusion. So in this presentation, we have reviewed TxID technology, which is adopted in ATSC 3.0 standards. Of course, there are multiple application scenarios for TxID, but basically TxID was proposed to help broadcaster design SFN by adjusting delay offset and transmission power of each transmitter. So through the computer simulation, laboratory tests, and field tests, we have confirmed that the detection performance of TxID is degraded by 3 dB when the number of transmitters is doubled. So based on the results presented here, it seems very necessary to improve TxID detection performance in the multiple transmitter scenarios. So there is another research work doing by ourselves to enhance the detection performance, and I guess the related paper will be published in this year. Thank you.